lesson 3. This should be a lot of stuff that we kind of know. If you look through, I think it's on page like 26 in your book, you'll see at the bottom where lesson 3 actually starts. And you can see the heading, what this lesson covers. Right off the bat, you see Pythagorean theorem. By raise of hands, how many of us are familiar with the Pythagorean theorem? Every hand went up. Very good. We're also going to talk about a little bit about triangle inequalities, similar polygons. What do we know about things that are similar? No. If they were congruent, we would say that they were congruent. What do we know about similar? Close to the same. Like what, for instance? I mean, what would be a definition of similar figures? Same shape, different size. That's very good. Thank you. All right. And so we have similar polygons, but we'll also talk about similar triangles. In math, whether it's geometry or algebra 3, we're going to talk a lot about triangles. Okay. All right. So all that stuff is in this lesson. You can look through some of the things that are in the book, similar triangles, so on and so forth. It's really, they got a lot of different practice questions, but I'm going to get through some of this stuff. All right, question number 1. In the figure shown below, it says square. You see a question like this, you really want, there's some words that I have learned are really, really important, okay, because they tell us or they give us a lot of information in one word. For instance, square, okay? Why do we think the word square might be important? What do I know about squares? All sides are the same length. So if they give me one little piece of information, suddenly I know a lot of different things. What else do I know about squares? All angles are 90 degrees. Very good. That's also important here. Because if I end up splitting this square somehow into triangles, what kind of triangles would I be creating? Right triangles. And I know a lot about right triangles, right? We know that we have 30, 60, 90 right triangles. We know we have 45, 45, 90 triangles, right? And if I'm dividing a square into a triangle, what kind of right triangle am I dividing it into? A 45, 45, 90, which has a ratio of 1 to 1 to radical 2, right? So you see how just by underlining the word square, how much information that I've been able to come up with, right? And I haven't even started solving yet. Next thing it says that the square is inscribed inside of this circle. Okay, and we know some things about circles, right? We know that circles have radiuses or radii, and that is the distance from the center of the circle to the outside edge of the circle, correct? Great. All right, we also know that OM is perpendicular. How do I know it's perpendicular? Because I know what the symbol for perpendicular is, okay? We know that OM is 3, so I can go ahead and fill that in there. We want to find the area of the shaded region. Oh, how do I do that? Okay, so with a question like this, what I want to start with is I want to take the basic premise, the basic equation that I want to work with, before I've even got any symbols or anything in this. How can I find the area of a shaded region in this case? Take the square out of the circle. So basically what I'm going to say is I know that it is the area of the circle minus the area of the square. That gives me some place to start, right? What's the easiest thing to find in that equation? Area of the square. If OM is 3, what is the side length of the square? 6, because if I continued, if this is in the middle and I'd go up, that would be another 3. That means the height of the square is 6, which means all the sides are 6, right? So what do I know the area of the square to be? 36, because the area of a square is side squared. The side is 6, so 6 squared is 36. So I already know I'm going to subtract 36 from this. Okay? Now, let's go to the other side of things. What do I have to find? Area of the circle. What do I need to find the area of a circle? A radius. Is OM the radius? No, it's not. Okay? But I can draw a line that would be the radius. Okay? And it would go from here, the center of the circle, to there. Okay, the reason I do that and not this, because I can't do anything with that, right? Okay? Okay? So I'm going to draw, and I'm going to use as much of the square as I possibly can. I know this is 3. Okay? I know this is a right angle. Okay? What is that degree right there? 45. Okay? So that must be 45. Okay? Which means if this is 3, then this is 3, then this is 3 radical 2. Right? Does everybody know that? Everybody understand that? I get everybody's heads wobbling up and down. I've not lost it. Have I lost anybody? Because we can solve this a different way. Okay. So now I know the radius of the circle, right? All right. So I can do pi 3 radical 2 squared. But I can simplify that, right? What's 3 squared? What's radical 2 squared? 2. What's 9 times 2? 18. So I know that my answer is 18 pi minus 36. And did they give me any kind of units? Units squared. Okay, let's check. 18 pi minus 36. Very good. All right. So what I want you to get out of this is reasoning skills. Okay? How do I take information and reason my way into an answer? All right? Do you guys think that you can take the work from number 1 and solve question number 2 on your own? Okay? I'm going to hit pause on the video. You guys are going to work through number 2. Okay. We've got some answers out there in the world. Christian, what did you get for an answer? 32 pi minus 64. David? 32 pi minus 64. 32 pi minus 64. Okay, we got some of the answers floating around. 32 pi minus 64 is the answer. Does anybody need any help with that? No, we all feel pretty good. We could have gotten there if we had more time. Michael, did you get close or did you get it? Got close. Okay. All right, let's erase. Nope, that's not what I want to do. Use the biggest eraser possible. All right, let's come down here. Number 3, the lengths of the sides of a triangle are 9, 12, and 15. Is the triangle a right triangle, an acute triangle, or an obtuse triangle? Okay, so this is something that you should have written down from last year, but you might have forgot, which is how can I look at triangle inequalities and determine if a triangle is going to be obtuse, acute, or right. Everything is based upon the relationship with what? The hopeful hypotenuse, the longest side, the relationship with the longest side. So in a right triangle, we would say a squared plus b squared equals c squared, and that would be a right triangle. But it doesn't always. In fact, sometimes it's greater than c squared, all right? Or c squared is small, okay? So it is acute. If the longest side is too small, it will be acute, okay? If the longest side is too big, okay, it's going to be obtuse. Okay, now I'm going to erase that so that we can work, but you should probably write that down because it will be a quick way for you to figure out that type of question. Now, what is my longest side in this question? 15. So what we're saying is that what is the relationship of 9 squared plus 12 squared in relation to 15 squared? I know 15 squared is 225. I know these are 81 and 144. What is 81 plus 144? 225. They equal, so it is what type of triangle? Right triangle. Very good. Okay? Does that kind of quicken things up for us a little bit? The more we know, the quicker we can work. Okay? All right, determine whether the numbers represent the lengths of the sides of an acute, a right, or an obtuse triangle, or I guess in some cases, no triangle. Okay? Let's see. So we should be saying 6 squared plus 8 squared in relation to 10 squared. Some of these you should recognize as Pythagorean triples. And a Pythagorean triple will always be a right triangle. 3, 4, 5 is a right triangle. Okay? Which if I double 3, 4, and 5, I get 6, 8, and 10, and so I should see this as a right triangle. Or 36 plus 64 equals 100, right? So we see another right triangle. All right. Question number 5 gets a little bit more complicated because it would be easier for us to do is to actually kind of blow this up a little bit. We're looking at different things here. Let me see. I'm going to put this on the board. Now, if you go back and try to watch this, you're obviously going to miss what I'm going to cover because it's going on the board, not on the screen. Okay? So try to take good notes here, I guess is what I'm saying. All right, let's make this a little bit bigger. And one of the things I'm going to do as I do this is I'm actually going to split this into 3 separate triangles. Okay? So because these are all going to be similar, and similar triangles are proportional. Okay? So actually, I really just need 2 triangles, don't I? Let's just do 2. Okay? So let's start off here. What we've got is 35 here and 20 here, okay, on those upright legs. Then this is actually B plus C. A lot of people just put B there. Okay, it's B plus C because it's the whole thing. This is C. That's our hypotenuse. Okay, and there and across the bottom, we have A plus 48. Okay, and 48 for a short one. Okay, so it wants us to find A, B, and C. The easiest thing to find is from our little triangle, which is C, right? Because that's our hypotenuse. We would do 20 squared plus 48 squared equals C squared. So let's see, what do we get out of that? C should be 52, right? Okay, can we do that? That's the easy one. All right, the rest of these are a little bit more difficult. So we're going to set them up as proportions. So 35 over A plus 48 equals what? What does that equal on the other side? What is to 35? 20. And what is to A plus 48? 48. Okay, so we can take 35 times 48. Okay, cross multiply. 1,680. Okay, so that's what I get here, 35 times 48. And then this is 20A plus, what's it? 960. Okay, now we're going to subtract 960 from 1680. Oh, sorry. 720 divided by 20. A equals 36. Okay? And finally, B, which is the same thing. So we could go ahead and do, I like to use as much of the same math as I possibly can because it saves me from having to, I don't have to recalculate it. I've already calculated it. So if I keep 35 over 20, or 35 in relation, I'm going to do 35 over B plus 52. Okay, because I already found 52, so I know what C is. Equals 20 over 52, right? Okay, a little different, but I've used some of the things that I already knew. All right. Or we could have plugged in A and gotten that whole number, and that would have maybe saved us a little bit. I don't know. What's 35 times 52? 1,820. And then we've got 20B plus what? 1,000 what? 1,040. Okay. Subtract 1,040 from 1,820. 780 divided by 20. 39? Okay. Okay, 52, 36, 39. Can we do that? Split those triangles up. Okay, you can look at them separately, but keep them oriented the same way so that you can see the relationships. Okay? A lot of it kind of comes down to just being able to draw things in a way that you can get it. If that'll move. I know we're running low on time here. Basically, 6, 7, and 8 are pretty similar to the one we just covered. They're a little bit different orientation. 6 has the same orientation. 7 you would split just the way we split it. 8 is probably the toughest question on how to split that up. But I think you guys should be ready to go with this homework. So we'll end it right there.